So we have the next speaker, Lebin Cheng from Imperva. And are we ready, Lebin?
Yes, I am.
Yes, good. And you have your slides there and everything seems to work. So Imperva is where are you based? Just to get some.
I'm based in California, so it's starting of the
California,
day for
yeah.
me.
Okay. Yeah. So you please try to stay awake for us this early. Okay. Go ahead and start your talk.
Sure, thank you. So yeah, as introduced, my name is Lebin Cheng. I'm head of API security. I joined Imperva through an acquisition, and Imperva in mid 2021 by purchase a company, acquire a company called Cloud Vector that is focused on API security, and Imperva rolled us into their portfolio. And today I'm going to talk a little bit about security aspect and how actually security is a very key enabler for organization that is out of compliance, out of security concerns, and actually need to add security to APIs to secure protect the APIs. I actually should not have to talk too much about this particular slide because I'm talking to audience of API days, and you probably are developers or operators that deal with APIs all the time, and probably not a surprise to you that API actually is really past the hockey stick, right? It's being adopted extremely widely. But I want to point out one thing though is that in my conversation with many security operators, and API is actually starting to get to their uh, get their attentions basically. And a lot of security professionals that I talk to, and especially those who work in what you call maybe conventional companies, and they are starting to have a very aggressive stance, very aggressive digital transformation pace, and they're actually adopting API really rapidly. And if you can only look at a one indirect indicator, and you look at how popular API gateways are, right? API gateways or API management gateway, if somebody talk about it, or API access management gateway, if you talk security. And those are companies out there that provide API gateway to conventional applications, right? And expose API for integration purposes, or expose API to external users. So, for example, a integration with a cloud-based application does not need to go through a private VPN, and because setting up network connectivity and managing it is a lot of overhead, and API is so much easier to use. However, several security CISOs or security professional actually mentioned that actually exposed one security problem, which is API gateway itself. It has authentication, authorization built into them, but they are not built in to be a network security device. But by putting an API gateway in front of a otherwise internal application, internal facing application, and expose API to business logic and critical data, and in some way, actually, you're exposing something that you're making the API gateway like a application firewall. And so that could be the issue, because now the API that is created by developer, and developers should have all the freedom to create API, to modify the API to fit the business need. But we do not need to force developer to always be a security professional. So the tools are needed actually to enhance the security monitoring of those transactions or API transactions, so that security people are not going to be left behind by their developer as they adopt API and as their organization adopt API. So that's where we come from, and that's actually motivate the uh, founding of Cloud Vector, and working on API security, and actually that motivate Imperva actually jumping into the API security offering. And so in the remainder of this section, I'm going to explain to you our focus and what we see API security is going. And this is just a couple of API challenges. A lot of the security problem, because it's not fair to say API are risky or API not secure, and API has to expose some critical business logic and some sensitive data to for many of application to work, because that's its job. But the security risk come from the mismatch, there's a gap between the conventional security tools and conventional perimeter tools, and also the conventional method of security professionals. A lot of those security tools are heavily relies on predefined policies and predefined rules, and they are not flexible enough to actually keep up with the changes. And that's why there's some statistics out there, and some of them are very concerning, and I'm showing some of them here. And like only 50% of some of the organizations APIs are actually considered managed. Right? They are managed by security professionals, and they are exposed. And for one example, right, APIs sometimes have API specification, but API specification itself can be treated as a documentation, and it may or may not always up to date and match the API corresponding APIs implementation. And that could be an issue for security, because you do not have a good understanding of exactly what that API service is. And when I speak to many teams, security team especially, I said, your organization use API. Do you have an up-to-date API specification? And many of them, actually majority of them, say, no, I don't have any. And even if I have, and I go back to the developers or the operators, they said, well, don't trust it, don't enforce it, because that there are some security device you can actually enforce against the API specification, but if you do, it may end up with false positive. So that could be the gap, because you cannot just leave the API themselves unmanaged or expose them to data breach and things like that. And there are actually a new crop of attacks, or new way to attack API that is a lot more evasive, and so that actually make APIs even more risky. And because many people actually, when I talk about the importance of API security, they come back and say, well, I have an API gateway, for example, and the full name for the API gateway from a security perspective should be called API Access Management Gateway. And you do authentication, it authenticate the token, but there are many attacks out there. I'm not going to name names, because Imperva policy does not allow me to talk about specific incidents, but think about an incident in a social media company maybe 1 or 2 years ago that you're already aware of, that user A can log in, but through invoking some backend APIs can get user B's token, and then actually impersonate user B and try to get user B's data. And that's typically in a OAuth API security top 10 is kind of the top one, that broken object level authorization. And that kind of attack, if you look at the API call being made to complete the attack, they are actually, they can pass the authenticator, right? They can pass the API gateway. And all the APIs actually conform to a schema, even if you have a schema, because the schema only enumerate the endpoints, the parameters, and the parameter types. But many of the parameter types are character strings or integers, right? There's only so many generic types. But the character strings that contain personal identification information is completely different from a security perspective from somebody that's just a user comment, in the string. So that's why we do not want the application to have to left to fend for themselves. So that's the key. But when the application are left to fend for themselves, a little bit of bug, a little bit of vulnerability in the application will result in the bad actors can take advantage of that bug. And also because those bugs tend to evade all the detections, and some of those vulnerability actually stay there for months or years, and that resulted in a long window opportunity for bad actors to come in to exfiltrate a large sum of data over time without being noticed. And that is actually the key concern there. So, I want to quote Gartner here. There's a very widely quoted Gartner quote that, in 2022, which is this year, actually, this prediction was made many years ago. and it said API abuse can be the major factor for data exfiltration for the enterprise. And for a lot of security folks, and losing data is actually probably top one or two, and most of them are top one concern. Because I'm talking to probably a European audience, and this is actually maybe even close to hearts, because European actually many countries have very stringent rules and very about user data. And if a bank or if a organization lose user data, is a big deal, and there's a lot of a penalty and all that associated with it. And when you look at API data breach, and I talk about there's a new kind of attack, and that get a lot of attention. But I also want to remind everybody that also API is part of a web application. So the web application attacks can also be effective against a API calls. For example, end of last year, the Log4j attacks is a root awakening that the injection and also injections can also be made into injecting into API parameter, and injection can still be effective against certain applications. But there's also the application-specific attacks that does not have a commonly known attack patterns. Because if you look at an Log4j injection, you can tell from the request that and also Log4j injection apply to all applications, regardless how you implement an API. As long as I can inject it and your application is using Log4j, then you are susceptible to it. However, the attack that I just talked about, that are trying to kind of break the object boundaries, right, of the application, and those kind of behavior are specific to application, and they do not have any known patterns, and the combination of those two can be damaging. And that's actually why, if you look at the OWASP, the Open Web Application Security Project, they list the API top 10 type of category of attacks. If you look at all of them, actually require a stack of solutions. It's not a actually single API security solution. You have some API security company come out there and say, I do OWASP API top 10, but you have to double click and look into the details. For example, a lot of those highlighted in blue, in yellow here, they're actually best addressed by some conventional means, if I can make, of protections. For example, injection and good old injections. The web application firewall can be extremely effective against those kind of injection attacks. And a lot of the APIs, they are being used because API is a programmable interface. So they are being used by a bot, but it's not on. So it's a question of not, whether or not the API will be allowed to be used by a bot. It actually technically on the client side is always a bot, but whether or not it's a good bot versus a bad bot. An API can also subject to API level DOS attacks, and DDoS prevention is extremely important. And last but not least, authentication. Many people, security people jokingly say that the API token is kind of like a username password, and only the case that the username is built into the password, and tracking the token and making sure that the account take over. In many cases, actually, what we observed was the result of account takeover. People are not satisfied with just account takeover and try to log in manually. People are actually trying to use the credential to actually generate tokens and use the token to automate attacks. So API is a double-edged sword. It can be used for good purposes to automate your business logic and your business and your critical business function, but also can be leveraged by hackers, right, to automate the hacking, to slowly steal data from you. And that's the issue, because the hacker does not actually, the cost for the hackers in terms of time and effort actually is really low. Once it break open the API, it can use the API to automate it. But then for the blue ones, I sometimes call them the blue attacks, the big fours. Those are actually the unknown attacks, right? Those are the application-specific attack that usually you do not have a signature, you do not have a rule against it, and you do not even have a set of heuristic against it. So that's why, in order to have the security device better understand your application, or better fit the application, you cannot just come in and just say, hey, because it's application specific, because it's unknown attacks, I use AI and ML. Of course, at a high level, that's the idea, AI and ML. But AI and ML, how? How do you apply it? Right? It's not just like AI and ML. It's just a panacea to solve all problems. And I break it down into a couple of steps in order to understand the API. And the underlying assumption is you have to see the API. You have to be able to inspect the API. And that's actually the friction comes in. Is a lot of the in the past, a lot of security folks and say, in order for me to monitor your API, or even just to protect your API, you have to install some kind of a firewall in front of the application, or you have to modify your application in a certain way, or even compile in with a library or inject a shim or agent. And that kind of practice really actually fly in the face of digital transformation into the freedom that the developer has when they adopt the cloud, right? To have rapid development, and now security folks comes in and slow down your development. So having some kind of tool to come in, and I liken it to be a API security camera. They can come in to monitor the application without actually the application team or the developer had to do heavy lifting or have to modify the application, and that's key. And that allow us to then discover the API. Remember, I talk about the API specification is not always available, and we could actually look at the API calls, just like you have a facial recognition security camera, you look at the flows, and then you actually can recognize, and you can actually almost reverse engineer and come out with up to the API specification. So now you know where the data is. You then can actually try to detect the anomaly, because now you have a very good understanding, and then you can apply some proven AI and ML techniques to actually look for the anomaly, look for the out of ordinary data flows, and then in a typical detection and response manner, you can respond to it. And I add one last piece to the puzzle, is the verified puzzle, is because because we have this tool to actually help understand the API, and sometimes the tester of the API actually they actually want our help for them to actually enhance the security testing or even just general testing of the API. And because we have that real-time monitoring, we could actually provide them real-time usage of the API, and that helps them actually craft or automatically generate additional test cases to better test the API and make the API test actually closer to what they would expect from the reality. And as I mentioned, API security starts with discovery, and the discovery has to be automated. You just cannot say, hey, discovery meaning I lock my developer in a room and beat them up and ask them for up-to-date API specification or what the API do. It's never going to work. And also, Imperva especially, focus on data security, and actually that's what the focus of Cloud Vector as well. And we actually not only look at what API call will look like and what the parameter, but also what kind of data it is. So we have an automated data labeling technique. So we look at API just like a facial recognition camera, as I said, right? We recognize the sensitive data, and then we recognize the sensitive data flow within particular API. So this is actually a screenshot of one of our consoles, and you can tell all this data label generated automatically and updated automatically. And for the security teams, this is an extremely important first start, because they treat API as a very important security asset, and this is actually an inventory of the security asset. And as I mentioned before, flexible deployment is extremely important, although it's not just a convenience, right? It's a must, because you don't want to slow down the developers. And Imperva is a cloud WAF provider. It provides WAF gateways as a SaaS. So for our existing customer, it's very easy because the API flow through our WAF in the cloud. But for other customers who have, for example, have their private cloud and we have a collection what I call micro sensors that can plug into your application, without any modification of the packaging. Your application container remain completely the same. It's an extremely lightweight mechanism for us to actually plug in. If you have existing gateways or API gateway, we can plug into those as well. But there could be other APIs, especially those API under test. We can still monitor them using the microsensors. And that will collect the data, that kind of the security camera, and then we actually process it and we discover and detect. And I would like to conclude with presenting you a typical customer journey. And this is actually a couple of our existing customers. They started that way. And we break it down into the build, test, run, and API. In the build and design stage, we think about them as governance, right? Govern the API design. And then on the operation, it's a security operation. And for a lot of customers, they already have API being used in production. So we actually go back and we install this camera. We start discovering, and we actually find the API behavior, find the API inventory for them. Then actually we can go back to the build stage, because we go back and look at the API specification that is sitting in a repository somewhere, and we compare the two and we validate. And that itself is extremely valuable as well, and also is extremely valuable for even the developers, because some developer actually inherit the application, right? And or some application actually is come from the open source and they just borrow it, and now we know how they're actually being used. And in using that, we can then automatically generate additional test cases. For example, if this API is used in a certain way, or the parameter are passed in a certain way, of course, some of the parameters are data, they can be sensitive, but we can mask those data. We can change it, but we can fill it in different value, and then we can give it to the application's tester, especially security tester, to further test the API services based on our finding. And we do it in a loop. This can be automated, so it's not a one-time thing. And whenever the application changes, we can go through this loop again and again. And we already help some customers started this journey. Some customers are stage 1, some are moving to stage 2. And your journey may be different, but invariably we have a way for. And I to conclude, we have a API security tool that can help you monitor the security usage of your APIs in a way that completely would not slow down your application developer. Would in some way, actually, because we provide that security protection and the guardrail for your application, it actually help you, give you all the freedom to innovate for developers, and to even accelerate your digital transformation, because now you can digitize freely and securely. So love to hear from you. My contact is simple. It's lebin@imperva.com, and please visit Imperva as well, and give us a look.
Thank you, Lebin. It was a very, very clear talk, and I saw the audience was having a lot of chatting around why is Finland so concerned about API security. Well, I think that there was just so many of you great sponsors and speakers wanting to come, and I think this was like tying up a lot of the talks that we had previously about exactly having like data security and all the bits and pieces together. And I think that this is kind of like, what do you think that, because often API security is actually a very decentralized exercise, I would say. There are programmers, and there are like the network guys, and there are application developers and all kinds of other people, data people, and everybody's kind of like there, and nobody's actually maybe handling the whole picture. So is this the fix?
I hope so, yeah. Because the fix actually is to have a lightweight tool that the teams can work together without getting in each other's way. And I think that's the key, and that's the design principle of a tool like this. Because in the past, oftentimes, a developer say, hey, I'm here to just develop the application, and I give it to the operator. And the security operator say, hey, I'm here to make sure the developers' mistakes are not going to hurt us, right? And that's the wrong mentality. And a lot of times the conventional tools, they're at silos, as you point out, right? And they don't talk to each other. And in this case, all we need is just like how we want to secure our home, right, or secure an airport, right? The airport has a checkpoint, right? But you can only have a single checkpoint. But in order to enhance the security, you cannot just keep adding checkpoints or having people go through a lot of checkpoints. And that's why this kind of security camera could imagine a factory floor, and you can have the invisible camera, and you can actually keep a tab on the application and the operation, and how even keep a tab on when it's being designed and when it's being tested, and you can connect the dots, and that actually give a lot of insight to multiple teams to work together. So that's a great question.
So last year everybody was talking about observability, and everybody was building that into the traditional API gateways and other cloud environments. So how do you see that, and why wouldn't the gateways be an answer to this problem?
Yeah, the gateway can be the beginning, So actually, in my experience with customers, oftentimes if they have a gateway, we can tap into the gateway, and the observability efforts that is made by the overall industry, and I think by a lot of developers to instrument the code so that you can build in observability is extremely important, and I think it is a very good move in the right direction. However, my experience has told me that it's about 50-50, or maybe even not 50-50, because there's a lot of applications still created in the old days, and they are still in the monoliths, and they go through a gateway or say F5 load balancer application deployment, ADC, and they not necessarily go through an API gateway, and only a fraction of the functionality goes through an API gateway. And the remainder, there could be other, lightweight applications that directly without a gateway, make calls to the backend and expose some API. And those, that's actually, remember earlier in my deck, I mentioned only 50% of the APIs are considered managed, and the managed definition is managed by some API management gateway. And so only 50% of them. So there's still a lot of what we call shadow API or runaway APIs out there. Yes.
Great. Okay. Thank you, Lebin. And we will continue the program and keep those